Let yourself arrive here. Wherever you have been today, whatever you carried, whatever you solved, whatever remained unsolved, whatever was said, and whatever was left unsaid, let it be somewhere else for a while. You don't have to process it now. You don't have to prepare for tomorrow. You don't have to do anything at all. You just have to breathe. Take one slow breath in. Fill your lungs from the bottom upward, belly first, then ribs, then chest. Hold it gently, just a moment, and release it slowly, all the way out. Let your body follow the exhale. Let your shoulders fall. Let your chest soften. Let everything simply settle. Again. In, hold, and slowly out. Notice how your body responds to a deep, slow breath. It knows what to do with it. It begins to shift, almost immediately, from the alert mode of the day into something quieter, something older, something that knows how to be still. Take one more breath like that. In, hold, and out. Slowly, all the way out. Good. Bring your attention to your face now. Notice the muscles of your forehead. Let them smooth. Let the slight tension that accumulates there, from concentration, from screen time, from the 1,000 small expressions that make up a human day, just release. Let your forehead be as smooth as calm water. Your eyes, they are closed now. Let them stay closed. Let the muscles around them be soft and loose. Let there be no effort in keeping them closed. Let them rest, gently, in the dark. Your jaw, the hinge where so much tension collects without our noticing. Let it soften. Let your teeth part slightly. Let the whole architecture of your face go completely slack. There is nothing you need to express right now. No face to make for anyone. Your throat, open and easy. Breathing, unhurried. Your shoulders, let them fall. They've been holding something up all day. They can stop now. Your arms, heavy. Your hands, let them open. Each finger, soft and still. Your back, long and heavy against whatever surface is holding you. Feel the surface beneath you, accepting your weight, not reluctantly but completely, holding every part of you with exactly the same patient support. Your hips, heavy. Your legs, heavy. Your feet, the very last of you, heavy and warm. Your whole body is heavy now, pleasantly, completely heavy, the weight of a body that has done its work and is ready to rest. Breathe in, hold, and out. Tonight, there is something I want to tell you about. Not something invented, not something imagined, something real. Two creatures, both ancient, both living in the deepest, darkest parts of the ocean, both so rarely seen that for decades scientists weren't entirely sure they existed. The first is a shark, but not any shark you might picture, not the torpedo shape of a great white or the wide wingspan of a hammerhead. This is something older than those, something that has not changed significantly in 80 million years. An eel-shaped body. A mouth full of 300 teeth, each one curved backward like a fishhook. Gills edged with frills of dark red tissue, like the neck of a mythological beast, the frilled shark. The second is a squid, but not any squid you might picture either. Bigger than any squid anyone imagines, longer than a school bus, eyes as large as a human head. Not the gentle sucker cups of an ordinary squid, but hooks, sharp, rotating hooks on every tentacle, the colossal squid. We are going to find them both tonight, not by fighting, not by danger, by descending, slowly and quietly, into the world where they live, the world that most of the ocean is, cold, dark, patient, ancient, and extraordinarily alive. Breathe in, hold, and out. Let your body be heavy. Let your mind be open. The ocean is below us, and we begin. You are floating on your back, on the surface of the Southern Ocean, south of New Zealand, south of most things. The sky above you is grey-blue with the cold light of late afternoon, and the water beneath you is moving in long, gentle swells that come from very far away, from the open Antarctic Ocean where there is no land to interrupt them, where they can build and travel for thousands of kilometers. This is one of the most remote places on Earth, hundreds of kilometers from any shore. Almost no ships pass here. Almost no planes fly directly overhead. The ocean in every direction is simply ocean. And beneath you it is deep, very deep. But we have time. We always have time. Breathe in and out. The Southern Ocean is the coldest and most nutrient-rich of all the world's oceans. Fed by the upwelling of deep Antarctic waters, its surface teems with phytoplankton and krill in the summer months. Krill, small shrimp-like crustaceans barely a few centimeters long, exist here in concentrations that beggar imagination. A single swarm of Antarctic krill can cover hundreds of square kilometers and weigh millions of tons. The krill is the engine of the Southern Ocean food web. Everything eats krill: penguins, seals, whales, seabirds, fish, and the colossal squid, which grew to its extraordinary size on a diet that includes large fish and other squid. You float. The swells push you gently. Breathe. 10 meters below the surface. The swells are muffled now, their motion translated into a gentle rocking of the water column around you. The grey-blue of the sky has become the grey-blue of the sea, both directions the same cool color. A fur seal appears from the blue and circles you once at a respectful distance. Its eyes are enormous and dark, its whiskers trailing behind it as it turns. It regards you with the same calm assessment it would give a large piece of kelp. You are unexpected, but not alarming. The fur seal is a descendant of creatures that returned to the sea from land, perhaps 25 million years ago. Like the whale and the dolphin, its ancestors made the transition back, swapping legs for flippers, trading fur coats for layers of blubber, learning to hold their breath in an ocean they hadn't lived in for hundreds of millions of years. The seal does one more slow circle, and then, with a single powerful undulation of its hind flippers, it vanishes into the blue. Breathe in and out. 30 meters. The surface is a shimmering silver ceiling above you now, the swells visible as slow breathing in the light. Below, the water deepens in color. The blue of the Southern Ocean is distinctive, a deep, slightly greenish blue that speaks of its richness. The temperature here is noticeably colder than at the surface. The Southern Ocean is cold at the surface and colder still below. Its deep waters come from the Antarctic, driven down by the weight of the cold, salty water that forms when sea ice freezes and leaves its salt behind. This cold, Dense, salty water sinks Antarctic bottom water and flows northward along the floor of every ocean basin on Earth, the slowest and deepest river on the planet. The Southern Ocean's cold is not hostile, it is essential. The cold water carries oxygen from the atmosphere deep into the ocean. It feeds the deep sea with the nutrients that the surface world needs returned. Without the cold of the Southern Ocean, the entire ocean circulation system would be different. The whole planet would be different. Cold is not a flaw in the system. Cold is how the system works. Breathe in and out. 100 meters. The light is failing. Not dramatically, not in an instant, but progressively. The blue is darker here, richer, less transparent. Looking up, the surface is still visible as a lighter area of blue, but the quality of the light has changed. It is filtered now, attenuated, robbed of almost all its warmth and red wavelengths. You are entering the twilight zone, the mesopelagic. Here, the creatures begin to change. The bright colors of shallow water fish give way to silver, to black, to deep red, colors that function as camouflage in a world where there is just enough light to matter. A salp drifts past you, barrel-shaped, transparent, perhaps 10 centimeters long. Inside its crystalline body, a small loop of orange tissue, its digestive system, is the only visible structure. Otherwise, it is as clear as glass. It pumps water through itself with gentle contractions, filtering it for phytoplankton as it goes. Salps reproduce at extraordinary speed when conditions are right, asexually cloning themselves into chains of dozens, then hundreds of individuals, each one filtering the water, each one contributing to a chain that can stretch for meters, for tens of meters, pumping and filtering and moving and reproducing in the cold blue. And then, as the phytoplankton blooms fade, the salps die. All of them. Billions of salps sinking, a carpet of small, transparent bodies falling toward the seafloor, each one carrying its load of carbon from the surface world into the deep. A bloom and a sinking, a feast and a fast, a cycle that has been running for hundreds of millions of years. Breathe in, hold, and out. 150 meters. The photic zone is ending. Below this line, the light is too dim for photosynthesis. The green world, all the phytoplankton and algae that produce roughly half the oxygen on Earth and form the base of almost every ocean food chain, cannot function below this depth. A small lanternfish passes, its photophores pulsing once in a faint blue-green light. These tiny fish, most species are only 3 to 5 centimeters long, perform the largest daily animal migration on Earth. Every night, billions of lanternfish ascend from the mesopelagic to the surface waters to feed under the cover of darkness. Every dawn, they retreat back down, a daily tide of life, rising and falling with the sun. The lanternfish carries carbon downward with each descent. The organic matter it has consumed at the surface is carried into the deep when the fish descends, effectively pumping carbon from the surface into the deep ocean. This is part of the biological pump that helps regulate Earth's climate. The fish doesn't know this. It is just doing what evolution shaped it to do. And the consequence, unintended, is a service to the planetary carbon cycle that dwarfs anything humanity has ever done for the same cause. Breathe in and out. 200 meters, the last functional light. Below here, there is not enough solar energy for photosynthesis. The green world ends. The world of light ends. And the world of darkness begins, not all at once, but in the gradual, definitive way that the deep always does things. Marine snow falls around you constantly. You can barely see it, just the occasional flash of something small and white, caught at the edge of perception. But it is there, always there. The slow rain of the dead falling from above, carrying carbon and nutrients down from the sunlit world to the dark world below. The creatures of the mesopelagic are preparing for their nightly ascent. As darkness falls at the surface, hundreds of millions of small fish, squid, and crustaceans will rise from these depths toward the surface to feed. They rise every night in a migration so vast that early sonar operators mistook the ascending cloud of organisms for the ocean floor, the false bottom. Billions of creatures rising and falling with the sun, unseen, unannounced, the largest migration on Earth, every night. Breathe in and out, 250 meters. You are fully inside the twilight zone now, the mesopelagic. This zone, between 200 and 1,000 meters, contains the least known large-scale ecosystem on Earth. In terms of biomass, the total mass of living creatures in the mesopelagic may exceed the total biomass of all other ocean zones combined. All other ocean zones combined. An ecosystem larger than any other in the most common environment on the planet, and we have barely explored it. A copepod, tiny, barely 2 millimeters long, drifts past. Copepods are the most numerous complex animals on Earth. There are 1 quintillion of them in the ocean, 1 billion billions. They graze on phytoplankton at the surface and are eaten by almost everything else. They are the essential link between the microscopic plant world and the larger animal world. Without copepods, the ocean food web collapses. The copepod does not know it is essential. It simply feeds and reproduces and drifts, as it has done for 500 million years. Breathe in and out. 300 meters, the thermocline. The water above was between 8 and 12 degrees Celsius depending on the surface temperature. Here the temperature drops sharply, a few degrees over the span of a few tens of meters. This thermocline acts as a boundary, a wall of temperature that limits the vertical mixing of the ocean. Warm water sits above, cold water below, each layer staying mostly in its place. The cold, deep water is dense. Dense water sinks. This is the engine of the ocean's deep circulation. Differences in temperature and salinity driving a planetary-scale river of water that moves through all the world's ocean basins in a cycle that takes around 1,000 years to complete. The thermohaline circulation, the conveyor belt of the ocean. It regulates global climate, distributes heat from the tropics to the poles, ventilates the deep with oxygen from the surface, and carries nutrients that would otherwise be locked in the dark up to where phytoplankton can use them. If it were to slow or stop, as some climate scientists worry it might under certain warming scenarios, the consequences for global climate would be profound. The deep ocean and the surface atmosphere are in constant conversation. Through the water, through chemistry, through the patient circulation of the deep. Breathe in, hold, and out. 400 meters, The darkness is settling in earnest, now not complete, not yet, but thorough. The blue has become very deep, very dim, the kind of blue that exists at the edge of vision. A dragonfish glides past, and you catch it only because it carries its own light. 30 centimeters of sinuous, dark-bodied ambush predator, its chin barbel trailing with a bioluminescent tip that pulses a soft, greenish light. Along its belly, a row of photophores match the faint, down-welling light, giving the fish what scientists call counter-illumination camouflage. The dragonfish is patient in the way that all deep-sea predators are patient. It does not chase. It drifts, holds position, lets its lure do the work of drawing prey to it, and then strikes with a speed that makes the strike appear instant to any observer. A hinge in its skull unlocking, its head snapping back, its needle-fine transparent teeth closing on whatever comes too close. Patience and precision. The strategy of the deep. Breathe, in, hold, and out. 600 meters. The frilled shark lives at these depths and somewhat deeper, somewhere between 600 and 1,500 meters in the cold, dark water of the continental shelves and slopes, moving slowly through its ancient world. You may not see it yet, but you know it is there. The frilled shark, Chlamydocelicus anguineus, was first formally described by science in 1884 when specimens were collected near Japan. But it had been living in these waters in essentially the same form for at least 80 million years. Some estimates suggest the frilled shark lineage may be 150 million years old. 150 million years. The frilled shark was hunting these waters when the Tyrannosaurus rex was alive, and it looks like it. Scientists who first encountered live specimens often describe the experience as looking at something that should be extinct, like finding a dinosaur that had learned to swim and never left, breathe, in and out. The frilled shark is named for its gills, 6 pairs of gill slits, each one edged with a frill of dark, feathery gill filaments. On most sharks, the gill slits are neatly spaced along the sides of the head. On the frilled shark, they meet at the underside of the throat in a continuous, frilled collar, giving the shark the appearance of wearing a ruff, like a creature from an Elizabethan portrait. Its body is long and eel-like, not the torpedo shape of a modern shark, but something more ancient in its proportions. It moves differently from a modern shark. It undulates sinuously, using its entire body as a propulsive wave rather than the tail-driven swimming of more recent sharks. It is a swimmer from a time before sharks learned to swim the modern way. Breathe. 800 meters. The water here is very cold, 3 or 4 degrees Celsius in the Southern Ocean. Cold that has travelled perhaps from the Antarctic shelf, sinking under its own density and flowing slowly northward along the ocean floor. Cold that has been cold for a very long time. A hatchetfish passes above you, its upward-pointing eyes scanning the faint light above for prey silhouettes. Its body is flat and silver, barely a few centimeters thick, shaped like the head of a small axe. In the dim light, its metallic flanks catch and scatter what little illumination exists, making it shimmer and then disappear as it turns. The hatchetfish is present in every ocean on Earth, in the mesopelagic and upper bathypelagic, in numbers that are genuinely staggering. one of the most abundant fish in the world by biomass. They perform the nightly migration, ascending to feed and descending to hide, carrying their load of consumed organic matter downward with each dawn retreat. Breathe in and out. 700 meters. Marine snow falls in every direction. Drifting past you, each particle its own small story, each one a fragment of the surface world, making its long journey to the deep. The Southern Ocean's marine snow is particularly carbon-rich. The surface productivity here is enormous, driven by upwelling nutrients, and the biological pump is correspondingly efficient. Roughly 10 to 30% of the carbon fixed at the surface in the Southern Ocean reaches depths below 2,000 meters. In most of the ocean, the figure is more like 1%. The Southern Ocean is a carbon sink of extraordinary importance. It is absorbing a significant fraction of the carbon dioxide that human activities are releasing into the atmosphere. Without it, global warming would be measurably faster than it already is. But the Southern Ocean is changing. As the atmosphere warms, the Southern Ocean absorbs more heat and more carbon dioxide. The carbon dioxide changes the chemistry of the water, making it more acidic, a process called ocean acidification. Acid dissolves the calcium carbonate shells of many marine organisms, the pteropods, the foraminifera, the krill-adjacent organisms that are the base of the food web. The frilled shark and the colossal squid do not have calcium carbonate shells. Their chemistry is different. They may be less immediately affected by acidification, but the things that feed the things that feed the things that feed them may not be so fortunate. Everything is connected to everything. Breathe in and out. 800 meters. A fang-tooth fish materializes from the dark, Anoplagaster cornuta. Small, barely 15 centimeters, but disproportionately terrifying in appearance. Its head, relative to its body, is enormous. Its jaw is permanently slightly open because its teeth are too long to fit inside a closed mouth. The fangs of the lower jaw are the longest teeth of any fish, proportional to body size in the ocean, curved, glass-clear like needles of ice. They lock into sockets in the upper jaw to prevent them from piercing the fish's own brain when the mouth closes. The fang tooth is a visual horror that conceals a modest reality. It feeds on small fish and crustaceans. It does not attack things larger than itself. It is itself frequently eaten by larger deep-sea predators. In the dark, though, everything is more dramatic than the light would make it appear. In the dark, the fang-tooth is exactly as terrifying as its teeth suggest. Breathe in, hold, and out. 900 meters. The midnight zone is just below. Here, in the deepest part of the mesopelagic, the animals are sparse but present. A barrelly fish, Macropinna microstoma, drifts nearby, its transparent head like a glass bubble, its barrel-shaped eyes pointing upward, watching for the silhouettes of prey above. The barrel-eye's eyes are inside its head, visible through the transparent dome of the skull. This arrangement was not understood for a long time. Scientists who examined preserved specimens saw a face with two small nostrils where the eyes should be. Only in 2009, using live footage from underwater vehicles, did researchers discover that the barrel eyes were the mobile tubes inside the transparent head, and that the two structures scientists had taken for eyes were olfactory organs. The barrel eye had been misread for a century, because the living animal looks completely different from the dead specimen. So much of what we thought we knew about deep-sea creatures was learned from the dead. From bodies hauled to the surface and laid out in the light, bodies that had been compressed by decompression, discolored by death, distorted by the journey up. The living animals are different, more extraordinary. Breathe in and out. 1,000 meters, the midnight zone. The bathypelagic. From 1,000 meters to 4,000, the largest habitat on Earth, and the darkest. Not a photon of sunlight has ever reached this depth. None ever will. The pressure here is 100 atmospheres. 100 times the pressure at the surface. The weight of the water above, pressing in from all directions, is something that would be catastrophic for any unprotected human body. And yet life fills this space. Strange, adapted, extraordinary life. The frilled shark lives here, and a little above, and a little below. It does not hurry. It has never hurried. The frilled shark's body plan, the eel-like shape, the 6 gill arches, the terminal mouth at the very tip of its snout rather than the underside, as in most sharks, these are ancestral features. Features that were once common in ancient shark lineages and have since been lost in the vast majority of shark species. The frilled shark kept them because they worked, because the slow, sinuous hunting style in the mesopelagic darkness did not require the improvements that drove the evolution of modern sharks. When something works, the ocean does not change it. Breathe in and out. Something moves in the darkness ahead of you, not fast, not dramatic. A slow, sinuous movement at the very edge of perception. The frilled shark glides toward you at a depth of perhaps 1,100 meters. It is about 1.5 meters long. Slender and dark, its body the color of the water around it, a deep grey-brown that makes it almost invisible until it is very close. Its 6 frilled gill slits glow faintly against the slightly lighter ventral surface of its throat. Its eyes are large and oval. Adapted to the mesopelagic, where the dominant light is bioluminescent, single flashes and pulses from organisms scattered through the water column. The eyes of the frilled shark are suited to detecting movement, to picking up the contrast of a silhouette, to seeing in a world where seeing is itself a luxury. Its mouth, at the very tip of its snout, is slightly open. And you see the teeth. 300 teeth arranged in 25 rows, each tooth tricusped, 3 small points like a trident, and curved backward. Not like the flat, serrated teeth of a great white designed for cutting. These teeth are designed for gripping, for preventing escape, for holding something that struggles. If prey enters the frilled shark's mouth, the backward curve of 300 tooth tips makes escape almost geometrically impossible. The shark drifts closer. It is not alarmed by you. In its 80 million years, the frilled shark has encountered very few things that threatened it at depth. Its primary predators are other sharks and large marine mammals, which rarely descend to its preferred depths. It has evolved with little reason for alarm. It passes within a few meters of you, close enough that you can see the texture of its skin, dermal denticles, the tiny tooth-like scales that cover all shark skin, making it feel like rough sandpaper in one direction and smooth in the other. The frilled shark barely registers your presence. It continues past, unhurried, heading somewhere in the dark, going wherever it has been going for 80 million years. Breathe, in, hold, and out. The frilled shark was first described to Western science by a German ichthyologist named Ludwig Döderlein, who encountered specimens in Japan in 1879. The formal scientific description was published by Samuel Garman in 1884. But the frilled shark had certainly been seen before then, by Japanese fishermen who occasionally caught it in deep-sea nets, by sailors who saw it and described it as a sea serpent, by the ocean itself, which had known it for 80 million years. When the first specimens reached scientific hands and were laid out for examination, the scientific community was fascinated and puzzled in equal measure. Here was a shark that bore almost no resemblance to the modern sharks then known. Its gills were wrong. Its teeth were wrong. Its body plan was wrong. Scientists began examining its anatomy in detail. The frilled shark skeleton is made of cartilage, as all shark skeletons are, but the proportions of its skeleton are different from any modern shark, more ancient in their arrangement, echoing structures found only in fossil sharks from the Permian and Triassic periods. The frilled shark is, anatomically, a window into the Mesozoic ocean. It is as if, while the rest of the shark lineage was innovating and diversifying and filling new ecological niches in the shallow oceans, one lineage retreated into the deep and stopped. Not because it failed, but because it didn't need to change. The deep was stable. The deep was constant. The deep did not require updating. Breathe, in and out. The frilled shark was so rarely seen alive that for decades scientists pieced together its life from dead specimens caught accidentally in deep-sea nets or washed ashore. This was the fate of most deep-sea creatures before modern submersibles and deep-sea cameras. They were known from the dead, not the living. From bodies dredged up and laid out on laboratory tables far from their cold, dark world. The few observations of living frilled sharks on camera in their natural environment have confirmed what scientists suspected from their anatomy. They move slowly, they drift, often in a nearly horizontal posture, which is unusual for sharks. They use their long, flexible bodies to coil and spring when they strike at prey, a motion some researchers compare to a constrictor snake. The frilled shark can probably swallow prey up to half its own body length. Its jaws can distend dramatically, the way a snake's jaw unhinges to swallow something large. A feature that makes sense in an environment where prey is scarce and meals need to be counted upon for a long time. When you find something to eat in the midnight zone, you eat all of it. Breathe in and out. The frilled shark is also notable for the longest gestation period of any known vertebrate. Studies of specimens with embryos suggest that the gestation period may be 3.5 years, possibly longer. 3.5 years? In the cold, dark deep, the frilled shark carries its young for 3.5 years before they are born, already small, already complete, already ready for the darkness they will spend their long lives in. The ocean does not rush its most ancient things. Breathe. At 1,200 meters, the water temperature here in the Southern Ocean is close to 2 degrees Celsius. 2 degrees. Cold that would incapacitate a human in minutes. Cold that chills the thinking and slows the muscles and reaches for the core with patient, inevitable fingers. But the frilled shark is cold-blooded. Its body is the temperature of the water around it. Its metabolism, already slow by the standards of most vertebrates, is calibrated to operate at these temperatures. Its enzymes function at 2 degrees. Its nerve conduction works at 2 degrees. Its digestion works at 2 degrees. It is at home here in a way that we cannot fully appreciate from the outside. The cold that would kill us is the cold that the frilled shark evolved in. The dark that would blind us is the dark that the frilled shark sees in. The pressure that would crush us is the pressure that the frilled shark has never noticed. The deep ocean is not hostile to the things that belong to it. It is only hostile to us, and we are visitors. Breathe in and out. Let us think about those 300 teeth for a moment. Each tooth has 3 cusps, arranged like a trident, 25 rows of them, upper and lower, angled inward and backward. The angle is crucial. When the frilled shark closes its mouth, the angle of every single tooth tip points toward the shark's throat. Imagine trying to pull something backward through 300 backward-angled, tri-cusped teeth. You cannot. It is physically nearly impossible. The more a prey item struggles, the more it drives itself further into the trap of those teeth. Struggle becomes self-defeating. The frilled shark does not need to be fast. It does not need to overpower its prey with force. It needs only to get its prey slightly into its mouth, and after that, the geometry of the teeth does the rest. It is an ancient strategy, one that the ocean evolved 350 million years ago in the first sharks, and that the frilled shark has maintained in nearly unaltered form through every mass extinction. The strategy of the trap, the patience of the teeth, breathe in, hold, and out. 1,400 meters. The frilled shark has moved on. You watch it go, the slow, sinuous undulation disappearing into the dark, becoming less distinct, becoming shadow, becoming nothing. The midnight zone is quiet now, or as quiet as it ever is. There is a soundscape here that human ears cannot easily perceive, the very low frequency sounds of the ocean, the rumble of distant earthquakes felt through the water, the low pulse of ocean currents moving through deep channels, the occasional very low frequency click of a sperm whale somewhere above, its echolocation carrying down through the water in search of exactly the kind of prey we are going to visit next. A sperm whale hunting colossal squid. The colossal squid is what drives sperm whales down to depths that would be remarkable even for creatures adapted to deep diving. Circular scars on the skin of sperm whales, the precise size of colossal squid hooks, suggest that the encounters are not gentle. The squid fights, but the squid usually loses. Usually. Breathe in and out. At 1,100 meters, a gulper eel passes you in the dark. Eurypharynx pelicanoids, perhaps the most extraordinary jaw in the ocean. Its mouth is so large relative to its body that the entire front half of the animal appears to be a mouth with a small body attached behind. The jaw can open to an angle greater than 90 degrees, its stomach expanding to accommodate prey far larger than any observable feature of the eel's exterior anatomy would suggest. The gulper eel can eat something larger than itself. In the food-scarce midnight zone, this is not gluttony. It is survival strategy. When food comes, rare and unpredictable, take as much as possible. Store it. Survive on it for as long as possible until the next meal arrives. The gulper eel may wait weeks or months between significant meals. It survives by being prepared to take everything when anything is available. A lesson in patience and preparation for abundance. Breathe in and out. At 1,200 meters, the dark is not entirely dark, not because of any external light, but because of life. In the midnight zone, bioluminescence is the primary form of light. Every flash, every pulse, every slow glow is produced by a living organism using chemistry to make cold light. Scientists have estimated that up to 90% of the organisms in the deep ocean are bioluminescent. 90%. The ocean is not dark in the way we imagine darkness. The ocean is dark with exceptions, riddled with brief, cold, chemical light produced by organisms from bacteria to anglerfish to squid to siphonophores. Each flash of bioluminescence is a communication, or a lure, or a defense, or a sexual signal, or a confusion tactic. The midnight zone has its own language, written in light, a language that predates human language by hundreds of millions of years, a language we are only beginning to learn to read. Breathe in, hold, and out. At 1,300 meters, the clicking begins again. Low-frequency clicks traveling through the water, bouncing off structures in the water column and returning to the source, painting a three-dimensional acoustic image of the surrounding world. A sperm whale is somewhere above you, descending. Sperm whales can dive to depths of 2,000 meters, sometimes more. They hold their breath for up to 90 minutes on a dive. Their hearts slow dramatically during a dive from around 50 beats per minute at the surface to fewer than 20 in the depths. Blood is shunted away from extremities and toward the brain and heart. The myoglobin in their muscles, the same oxygen-binding protein that makes meat red, but present in sperm whale muscle at concentrations that make the flesh nearly black, stores enough oxygen to supply the body during the dive. The sperm whale is a machine built for the deep. Every system in its biology has been adapted over the 40 million years since sperm whales diverged from their terrestrial ancestors for the specific challenge of hunting in absolute darkness at crushing pressure. Its echolocation, the biological sonar, produces the loudest sounds of any animal on Earth, up to 230 decibels at source, powerful enough at close range to potentially stun prey. And its brain, weighing more than 8 kilograms, the largest brain of any animal that has ever lived, processes the returning echoes and constructs a detailed acoustic image of its environment. The sperm whale sees with sound. In the dark, breathe in and out. At 1,600 meters, you continue downward. The colossal squid, Mesonicoteuthis hamiltoni, lives primarily in the waters surrounding Antarctica. It is found in the Southern Ocean from the surface, where juveniles and smaller individuals range to depths of at least 2,000 meters, where the largest individuals are believed to live and hunt. It is difficult to be precise about the colossal squid's depth range because the colossal squid has almost never been observed alive in its natural environment. Almost everything we know about the colossal squid comes from dead or dying specimens, ones hauled up accidentally in fishing nets, targeting other species. Ones found in the stomachs of sperm whales. The beaks, hard and indigestible, accumulate in sperm whale stomachs in numbers that suggest the whales eat colossal squid regularly. The colossal squid was first formally described in 1925 from 2 arms found in a sperm whale's stomach. Not a full specimen, just arms. And from those arms, their size, their hooks, their muscle structure, scientists inferred the existence of something very large and very formidable. It took until 2003 before a complete colossal squid was photographed alive in the wild, until 2007 before a large adult was captured intact. That specimen, caught by a New Zealand fishing vessel in the Ross Sea accidentally while targeting toothfish, weighed approximately 495 kilograms and measured around 4 meters in mantle length. Total length, including tentacles, was around 10 meters, 33 feet, the size of a large school bus. Breathe in, hold, and out, 1,800 meters. The water here is as close to freezing as liquid salt water gets, just above the freezing point of seawater, which, due to its salt content, is about minus 1.8 degrees Celsius. The colossal squid is adapted to this cold in ways that go down to its biochemistry. Its blood contains hemocyanin, the copper-based oxygen carrier of most mollusks and crustaceans. Hemocyanin is less efficient than hemoglobin at transporting oxygen at warmer temperatures, but at low temperatures, in oxygen-rich cold water, it works well enough. And the colossal squid's hemocyanin has been specifically adapted through millions of years of selection to work in the cold Antarctic waters where it lives. The colossal squid does not shiver. It does not burn calories to maintain a body temperature different from the water around it. It is the water around it in temperature. Everything about its metabolism is calibrated for cold. Breathe in and out. Let your own body be warm where it is. Let the warmth of your bed, the warmth of the room, the warmth of your own biology be present and real. The cold of the deep is for the colossal squid. Your warmth is for you. 2,000 meters. The pressure is 200 atmospheres. 2,000 times the pressure at the surface of the ocean. 200 kilograms pressing down on every square centimeter of whatever exists here. A human body at this depth, unprotected, would be compressed to a fraction of its size in seconds. The colossal squid is not compressed. Like all cephalopods, it has no gas-filled spaces in its body, no swim bladder, no lungs. Just fluid and tissue and a hard, chitinous beak, the only truly rigid part of it. A body made mostly of water cannot be significantly compressed by water pressure. The colossal squid is made of the deep. It is, in its composition, almost indistinguishable from the cold water that surrounds it, except in its eyes. Breathe in and out. The eyes of the colossal squid are the largest known eyes of any living animal. Not just the largest eyes of any squid or any invertebrate, the largest eyes of any animal on Earth. The preserved specimen from 2007 had eyes approximately 27 centimeters in diameter. 27 centimeters. Roughly the diameter of a large dinner plate or a human head. These eyes have a pupil that can dilate to approximately 8 centimeters in diameter, wider than most human fists. The photoreceptive cells covering the back of the eye number in the hundreds of millions. The optic lobe of the colossal squid's brain, the part dedicated to processing visual information, is extraordinarily large relative to the overall brain. Why eyes this large? In the deep ocean, where the only light is bioluminescence, the scattered, brief flashes of organisms signaling and hunting in the dark, enormous eyes gather more light per unit time. They are more sensitive. They can detect a single photon. They can see a flash of bioluminescence from a significant distance. Scientists have proposed that the colossal squid's enormous eyes are specifically adapted to detect one thing: the bioluminescent wake of a very large approaching animal. A sperm whale's echolocation clicks disturb the bioluminescent organisms in the water, creating a luminous trail that betrays the whale's approach. The colossal squid may be able to see that trail from far away, far enough away to react, to retreat, to maneuver. The enormous eyes may be a defense against the one predator powerful enough to hunt it. Breathe in, hold, and out. At 2,100 meters in the cold and dark of the Southern Ocean abyss, something comes into awareness. Not through sight, there is nothing to see, but through the subtle pressure waves that large animals create in the water as they move. A presence. Something large, moving slowly in the water ahead. And then the eyes. Two pale discs, 27 centimeters across, catching the faintest trace of bioluminescence from somewhere above. They hang in the dark like two moons that forgot where they were going. The colossal squid drifts. Its mantle, the main body, cylindrical, muscular, is perhaps 4 meters long. The trailing arms and tentacles below it extend further, their total length difficult to judge in the dark. Its coloration is dark red-brown, common in deep-sea squid. In the blue filtering light of the deep red appears as black, providing camouflage against the darker water below while being less conspicuous from above than a paler animal would be. The squid moves with the paired fins at the rear of its mantle, two rhomboid fins that undulate gently, precise and efficient. It also uses jet propulsion when it needs speed, contracting its muscular mantle to force water through its siphon. But right now, it is not in a hurry. Right now, it is watching. Those enormous eyes scanning the water above, watching for the bioluminescent wake of a sperm whale. Breathe in and out. The colossal squid has 8 arms and 2 longer tentacles, as all squid do. But what the colossal squid has on its arms and tentacles is unique among all known squid species. Not suckers, hooks, sharp, rotating, chitinous hooks, each one mounted on a swiveling base that allows it to rotate freely. Along the length of each arm, hooks alternate with small sucker cups. On the tentacle clubs, the flattened, padded tips of the longer tentacles used for capturing prey, the hooks are concentrated and particularly large. These hooks dig into whatever the squid grasps. They penetrate, they hold, they grip from multiple angles simultaneously, and when the squid's muscular arms contract to pull prey toward its beak, the hooks drag through the prey's flesh with each movement. The scars on sperm whales' skin, circular rings of healed tissue, sometimes 30 centimeters in diameter, are the signatures of colossal squid hooks. The whale won those encounters, but the encounters left marks. The colossal squid does not go gently. Breathe in and out. At the center of the colossal squid's ring of arms is its beak, a hard, chitinous structure, the only truly hard part of the squid's body, shaped like a parrot's beak, dark brown to black, with a sharp, cutting edge and a mechanism for delivering tremendous force to a small area. The beak is powerful enough to crack the bones of large fish, powerful enough to sever the soft tissue of prey, many times the squid's own size. Beaks from colossal squid found in sperm whale stomachs suggest that some individuals may grow significantly larger than any specimen ever captured. The beaks in whale stomachs range widely in size, and the largest beaks found suggest animals with mantle lengths well above anything science has documented. How large can a colossal squid get? We don't know. We have never seen the largest individuals. They live where we cannot easily go, in waters that are remote and hostile, at depths that challenge even purpose-built submersibles. The largest colossal squid alive right now in the cold dark of the Southern Ocean may be significantly larger than anything ever caught or described. There may be something down here that makes the 2007 specimen look small. Breathe in, hold, and out. The colossal squid drifts. Its movement is minimal now. It is in what researchers call an ambush posture, nearly motionless in the water column, tentacles partially extended, watching. Many cephalopods use ambush strategies. No, wait. Detect. Strike with speed when prey is within range. The metabolic cost of this strategy is low. Staying still uses very little energy. The payoff, when it comes, is large. A meal that can sustain the animal for days or weeks. In a food-sparse environment like the deep ocean, this mathematics makes perfect sense. The colossal squid can afford to wait. It is not impatient. It is incapable of impatience. The emotional state that requires a sense of time, a preference for now over later, a belief that something better is just ahead if only the waiting would end. The colossal squid does not believe in better. It does not believe in later. It simply exists in the present, entirely, the enormous eyes scanning, the hooks ready, the beak waiting. This is not a diminished way of being. This is being, stripped of everything extraneous. Breathe in and out. The colossal squid, like many deep-sea cephalopods, has a neutral buoyancy mechanism based on coelomix fluid. Rather than a gas-filled float which would compress fatally at depth, the squid maintains buoyancy with a fluid rich in ammonium ions. Ammonium solution is slightly less dense than seawater, providing lift. This ammonium solution also makes the colossal squid's flesh taste unpleasant to humans, bitter and ammonia-rich. This incidental quality may have historically protected colossal squid from fishing pressure, since even the nets that caught them produced meat that most people could not eat. The deep ocean is full of such accidental defenses. The biological adaptations for survival in the deep often have side effects that, from a human perspective, look like fortune. Breathe in and out. The colossal squid's mantle is massively muscular. When it contracts for jet propulsion, the speed it achieves is significant, not the sustained speed of a fast fish, but the explosive burst of a creature capable of reaching a short-distance maximum that can startle even large predators. It can accelerate from stillness to a significant velocity in a fraction of a second. And when it retreats, it releases a cloud of ink, not the diffuse, widely spreading ink of a shallow water squid, but a concentrated, dark mass that hangs in the water like a solid object, potentially functioning as a decoy while the squid jets away. In the darkness, where the only perception is chemical and pressure-based, an ink cloud that holds the chemical signature of the squid can confuse a predator for vital seconds. Long enough to escape, long enough to disappear back into the dark. Breathe in and out. At 1,900 meters, the water here belongs to the abyssal domain. The Southern Ocean's deep water is Antarctic bottom water, the densest, coldest, saltiest ocean water in the world. It forms on the continental shelves of Antarctica, where sea ice formation removes fresh water from the ocean as ice and concentrates the salt in the remaining liquid. This super-dense, super-cold water sinks and flows northward along the ocean floor underneath warmer but less dense waters. Antarctic bottom. Water is the deepest layer of water in most of the world's ocean basins. The water at this depth may have formed at the surface of the Weddell Sea or the Ross Sea on the Antarctic continental shelf within the last few centuries. It sank there and has been flowing slowly northward ever since. This is relatively young deep water by ocean standards. Water in the oldest parts of the deep ocean has been isolated from the atmosphere for perhaps 1,000 years. The Antarctic bottom water here, perhaps only a few hundred years. Still ancient by human reckoning, but young for the deep. Breathe in and out. Not all colossal squid live at 2,000 meters. Juveniles range more widely. They have been found at shallower depths, even occasionally near the surface, in the waters around Antarctica. A juvenile colossal squid is very different in appearance from an adult. Smaller, obviously, a few tens of centimeters rather than several meters. More transparent, less muscular. Its hooks, while present, are smaller. A juvenile colossal squid looks like something from a science fiction film's concept art, rather than a real animal. Its eyes, even at a few centimeters, are already disproportionately large. Its intelligence is apparent even at this young age. Cephalopods are born capable, not helpless. A juvenile colossal squid can hunt from its earliest weeks of life. We know very little about how juvenile colossal squid develop, whether they school, whether they have any parental care, where they shelter, what they eat as juveniles. We know almost nothing. We have barely seen them. The sea keeps its young hidden. Breathe in, hold, and out. The marine snow falls around the colossal squid around you in the deep, cold water of the Southern Ocean abyss. At this depth, the particles are small, where the larger aggregates have been consumed on the way down, broken apart by bacteria and organisms in the water column above. What reaches 2,000 meters is the most resistant fraction. The mineral particles, the most recalcitrant organic compounds, the pieces that have survived the gauntlet of the upper ocean. Each particle that reaches the seafloor is a small victory over decomposition. A small piece of the surface world arriving intact in the deep. The Southern Ocean is particularly productive at the surface. All that krill, all those phytoplankton blooms, all that primary production driven by the upwelling of nutrient-rich Antarctic water. And the biological pump here is efficient. A significant fraction of that surface production makes it to depth. The deep Southern Ocean is not food poor. Not by the standards of most of the deep ocean. This is part of why the colossal squid can grow as large as it does. The energy available in the deep Southern Ocean is enough to sustain something very large. The colossal squid is, in some sense, a monument to the productivity of the surface ocean above it. Built from the krill and fish that ate the krill, that ate the phytoplankton that grew in the light far above. Energy from the sun, channeled through a dozen intermediate steps, assembled into something enormous and terrifying, and mostly unknown. Breathe. In, hold, and out. In the waters above you, a sperm whale is descending. You heard its clicks earlier at 1,400 meters and the rapid-fire sonar pulses of a hunting whale. Now the clicks are louder, closer, more insistent. The sperm whale is the colossal squid's primary predator, and the interaction between them is one of the most dramatic and least observed encounters in the natural world. The whale has been tracking the squid's position, perhaps using echolocation to detect the squid's hard, reflective beak among the soft tissues of the water column. Perhaps following the chemical signature of the squid's ammonium-rich body fluids, perhaps sensing the pressure disturbance of the squid's movements. The whale is faster than the squid over distance. It can sustain speeds that the squid's jet propulsion cannot match for more than short bursts. But the squid has those hooks, and a beak that can bite through whale skin. The encounter, when it comes, is brief and brutal, and occurs in total darkness at a depth where no human has ever witnessed it directly. We know it happens from the scars, from the beaks in whale stomachs, from the sucker ring teeth of squid found embedded in whale flesh. Two enormous animals in total darkness 2,000 meters below the surface of the Antarctic Ocean wrestling in the cold. One of them usually wins, but not always. Breathe in and out. The colossal squid's eyes rotate slightly in their sockets. The clicking of the approaching sperm whale is getting closer. The squid's chromatophores, the pigment cells that cover its skin and allow it to change color, shift. In the dark, color change is irrelevant, but the shift of chromatophores creates a slight change in the texture of the squid's skin surface, perhaps altering the acoustic signature it presents to the whale's echolocation. The squid begins to move. Not a panic run, not yet. A slow, deliberate repositioning, moving slightly deeper. moving toward a thermal layer where the temperature change might confuse the sonar return. Putting distance and water between itself and the approaching sound, its 8 arms curl slightly, tightening into a more hydrodynamic shape. Its fin undulations increase in frequency, barely perceptibly. The bioluminescent organisms disturbed by its movement flash briefly in its wake, tiny lights, each one a fraction of a second, marking its passage through the water like a trail of cooling embers. And then the squid accelerates. The mantle contracts with enormous force, water jets from the siphon, and the squid is gone. Not slowly gone, not gradually gone, but gone in the way that only something built for explosive movement can be gone, instantly, completely, a shadow that was here and then is not. The clicking continues above. The whale passes. The dark closes back in. Breathe in, hold, and out. After the whale departs, the water returns to something that might be mistaken for silence. But the Southern Ocean is never entirely silent. Low-frequency moans travel through the SOFAR channel, sounds produced by Antarctic blue whales. Somewhere in the distance, their calls, below the threshold of human hearing, but carrying for hundreds, perhaps thousands of kilometers through the still deep. There is a sound called the bloop. In 1997, hydrophone arrays operated by the National Oceanic and Atmospheric Administration recorded an extremely loud, ultra-low frequency sound in the Southern Ocean. It was called the bloop. It was so loud it was recorded by sensors thousands of kilometers apart. For years, its source was unknown. Speculation ranged from giant undiscovered animals to geological phenomena. In 2012, it was identified. The bloop was the sound of a large iceberg cracking and fracturing, a process called icequake, as it broke apart in the Antarctic waters. Not a sea monster, ice. Even the mysterious sounds of the Southern Ocean have scientific explanations when scientists look long enough. But the ocean is full of unidentified sounds. Sounds recorded by hydrophones that have no clear explanation. The Julia sound of 1999. The train sound. The whistle. The upsweep. Each one patiently catalogued, some explained, others still a mystery. The ocean is full of sounds we cannot yet interpret. Breathe in and out. The colossal squid is a cephalopod, and cephalopods are remarkable for their intelligence. The octopus, the most cognitively studied cephalopod, has demonstrated tool use, memory, learning by observation, what appears to be individual personality differences, the ability to recognize individual human faces. The octopus nervous system is distributed throughout its body. 2/3 of its neurons are in its 8 arms, not in its central brain. Each arm can act semi-autonomously, solving problems locally without waiting for instructions from the central brain. The colossal squid's cognitive abilities are unknown. Its nervous system has not been studied in the living animal in any detail, but the structural components of intelligence are there. A large, complex brain relative to body size, large, sophisticated eyes, chromatophore control systems that suggest the ability to produce rapid, complex signaling. The colossal squid may be more intelligent than any fish, more intelligent than many mammals. In the dark, at 2,000 meters, something large and intelligent waits. Its experience of the world, if it has one, is built from pressure waves and chemical signals and the rare photons of bioluminescent light. A mind built for the dark. Breathe in and out. The colossal squid does not experience the dark as absence. The dark is its medium, the way air is your medium. You do not experience air as absence of water. You experience air as the substance in which you move and breathe. The colossal squid moves and breathes metaphorically in darkness. Darkness is where its senses were calibrated, where its hunting strategy was shaped, where its enormous eyes evolved to see. The light for the colossal squid would be as overwhelming and disorienting as the pressure of the deep would be for us. We are each perfectly fitted to our world, and our worlds are, in some ways, more different from each other's than we tend to acknowledge. The boundary between worlds is the surface of the ocean. Above, light, warmth, air, the elaborate surfaces of continents and forests and cities. Below, dark, cold, water, the vast emptiness of the deep. Two worlds on the same planet, both full of life, both full of experience in whatever form experience takes. Breathe in and out. The water is still again. The colossal squid is somewhere in the dark, deeper now in the cold that no sperm whale has ever reached. The whale circles above, searching, its clicks slower now, more exploratory. Then it begins its long ascent to the surface, 90 minutes of holding breath, finally demanding air. You remain at depth, alone in the cold and dark, with the marine snow, with the pressure, with the memory of those enormous eyes, 27 centimeters across, eyes that have been looking out at this dark for millions of years, eyes that evolved specifically to see in a world without light, eyes that see by the light that life itself makes. Breathe in and out. There is something surprising about the colossal squid when you learn its metabolism. For an animal of its size, 1/2 ton, 10 meters of arms and mantle, its metabolic rate is low, extraordinarily low. A colossal squid needs relatively little food, given its mass. This seems paradoxical. Something so large should need enormous quantities of energy to sustain itself. But the cold water temperature slows everything. Every chemical reaction in its body happens more slowly at 2 degrees Celsius than it would at 20 degrees. The colossal squid's metabolic rate is calibrated to the cold. Scientists estimate that an adult colossal squid may need only about 30 grams of food per day. 30 grams for a 500-kilogram animal, one very large fish, or a few medium-sized ones per day. This low food requirement means the colossal squid does not need to hunt constantly. It can afford to wait. It can afford to be patient. It can drift in ambush for long periods, conserving energy, watching with those enormous eyes for anything that comes within range. The cold gave the colossal squid something unexpected, the luxury of patience. Breathe in and out. The colossal squid is not alone in these waters. At 2,000 meters in the Southern Ocean, the water is cold but not lifeless. Toothfish, Patagonian toothfish, the fish sold as Chilean sea bass in restaurants, range to these depths along the margins of the Antarctic continental shelf. They are large, long-lived fish reaching up to 2 meters and 100 kilograms, living for up to 50 years. They are one of the colossal squid's prey species, and they are hunted by the colossal squid and in turn hunt smaller fish and squid themselves. The toothfish is also one of the most intensively fished species in the Southern Ocean. It has been overexploited in some areas, and where the toothfish disappears from an ecosystem, what happens to the colossal squid, to the sperm whales that eat the colossal squid, to the ecosystem that depends on the connections between these species? We don't know. We are still learning how these deep-sea food webs function. Every species removed is a thread pulled from a fabric whose full pattern we haven't seen. Breathe. In. Hold. And out. The frilled shark is not alone in the deep. Several other shark species range into the mesopelagic and upper bathypelagic zones of the Southern Ocean. The Portuguese dogfish, Centrosymnus coelolipis, is one of the deepest dwelling sharks, recorded at nearly 4,000 meters, a small, dark, slow-moving shark that feeds on fish, squid, and crustaceans in the deep. The kitefin shark, Delatius licher, was discovered in 2021 to be bioluminescent. The largest known bioluminescent vertebrate on Earth, reaching 1.8 meters. Its entire ventral surface glows with a diffuse blue-green bioluminescence. Why? Scientists believe the glow may help it communicate in the dark or serve as counter-illumination camouflage or attract prey. A glowing shark, discovered to glow in 2021. A 1.8-meter shark living on the deep ocean, bioluminescent, and we only found out in 2021. This is what the deep ocean is. Full of things we thought we knew and didn't. Full of things we haven't found yet. Breathe in and out. The frilled shark eats mainly squid and other cephalopods. Squid make up the majority of its diet based on analysis of stomach contents from specimens caught in fishing nets. Alongside squid, bony fish, other sharks, crustaceans. The coiled, constricting hunting method that some researchers describe for the frilled shark is particularly suited to catching fast-moving, slippery prey like squid. A squid that is enveloped by the curling, sinuous body of a frilled shark has little direction in which to escape. And once the 300-tooth mouth closes, there is nowhere to go. The frilled shark likely hunts from below. Like many deep-sea predators, it may position itself below potential prey and strike upward. The underside of prey is often less well defended visually, and an approach from below reduces the chance of detection. Attack from the deep, from below, from the place no one is watching. The frilled shark's territory. Breathe. In, hold, and out. The frilled shark, somewhere above you, has its own relationship with time. In the world, without day or night, without any variation in light, without sunrise or sunset, does the frilled shark have rhythms? The question is more complex than it seems. Some deep-sea creatures have been found to have circadian rhythms despite living in permanent darkness. Internal clocks maintained by the animal's own chemistry that run on an approximately 24-hour cycle even without environmental cues to synchronize them. In the frilled shark, this has not been studied in detail. Almost nothing about the frilled shark's physiology and behavior in the wild has been studied in detail. What we know is that it moves slowly, that it exists in a world where energy must be conserved, that its 3.5-year gestation means it breeds very slowly, produces few offspring, and requires decades of life to replace itself in the population. The frilled shark cannot afford to be caught in large numbers. Its slow reproduction means any significant reduction in population takes a very long time to recover from. Bycatch. The accidental capture of frilled sharks in nets targeting other species has been documented, not studied well enough to know if populations are stable or declining, not studied well enough to know how many frilled sharks there are, not studied well enough to know if this 80-million-year survivor is in any danger from the activities of an animal that has existed for only a few 100,000 years. Breathe in and out. At 2,000 meters, the weight of the water above you is immense. The pressure is 200 atmospheres. 200 times what you experience at the surface. Every square centimeter of anything at this depth bears 200 kilograms of force. A submarine not built to withstand this pressure would be crushed instantly. The colossal squid does not experience this as weight. Its body is composed largely of water, which is incompressible. The same water that exerts the pressure is the same water that fills the squid's tissues. There is no crushing because there is no empty space to collapse. The colossal squid is not brave for living at this depth. It is simply built for it. It is made of the deep in the same way that you are made of the surface, your body shaped by and for the conditions of the world where you evolved. Sea level, standard atmospheric pressure, room temperature, oxygen-rich air. These are your conditions. They are not superior to the colossal squid's conditions. They are just where your particular arrangement of matter evolved to be comfortable. Breathe in and out. Your thoughts are quieter now. Perhaps they have gone quiet entirely. This is the threshold, the place between waking and sleeping, the hypnagogic state, where images form without narrative, where the logic of waking begins to dissolve into something more fluid and less accountable. You may have noticed your thoughts drifting, moving in directions you didn't plan, images arising that have no obvious connection to what came before. This is normal. This is the brain doing what it does when it is no longer managing the interface between you and the world, when it turns its resources inward, when it begins the work of rest. Let it. You don't need to steer. The frilled shark does not steer. It drifts in the direction the current takes it, making small adjustments, holding its position in a general way, but not fighting the water, not fighting anything, just being in the water. Be in this moment the way the frilled shark is in the water, without resistance, without agenda, present. Breathe in and out. The colossal squid's skin shifts again. Chromatophores, the pigment-containing cells in its skin, respond to neural signals, expanding and contracting in milliseconds to produce visible color changes. In shallow water cephalopods like the cuttlefish, these changes are used for communication, camouflage, and sexual display in an extraordinary visual language of pulsing color and pattern. In the deep, where there is no light by which to see color, chromatophore changes may serve a different function, or perhaps they are evolutionary holdovers maintained in the genome but rarely used in the dark. Some researchers believe deep-sea cephalopods may use chromatophore changes to alter their acoustic signature, the pattern of sound reflection that a predator's echolocation might detect. Others believe the chromatophores may be activated by bioluminescent light, that in a world of brief, cold flashes, even a small change in skin reflectivity could matter. The truth is, we don't know. We do not know what the colossal squid uses its chromatophores for. We do not know what the colossal squid experiences as it changes color in the dark. We do not know if the colossal squid experiences anything at all in the way we use that word. These questions may never be answered, and the colossal squid will continue to change color in the dark regardless of whether we figure it out. Breathe in and out. The frilled shark and the colossal squid occupy different parts of this deep world. The frilled shark tends to range from the continental slopes, the underwater margins of land masses, down into the bathypelagic, primarily in temperate and tropical deep waters, though specimens have been collected worldwide. The colossal squid is specifically Southern Ocean, a circumpolar animal found in all the waters surrounding Antarctica. They may never meet, but they are united in their ancientness. The frilled shark is a relic of the age of dinosaurs, unchanged for 80 million years. The colossal squid's lineage, the squid family Cranchidae, the glass squid family, is ancient too, their ancestors present in the Mesozoic oceans. Two creatures from a time before most of what we consider the natural world existed. Two creatures that outlasted mass extinctions. Two creatures that adapted in the deep to the cold and pressure and dark and found a way to continue generation after generation in the quietest and most unchanging place on Earth. The deep ocean is not just the home of ancient things. The deep ocean is why ancient things survive, because nothing changes there. Not in any time frame that matters to biology. The cold is the same, the dark is the same, the pressure is the same, the chemistry is largely the same. And when the environment doesn't change, the organisms don't need to change. They persist, patient, ancient, in the dark. Breathe in and out. You have been descending for a long time now, and you have been here, in this dark, in this cold, in this deep quiet, long enough that something has shifted in you, something that is not quite thought, not quite sleep, but not quite waking either. You are at the threshold, the place between, the mesopelagic of consciousness, not the sunlit zone of full awareness, not the midnight zone of sleep, but the twilight zone where images form without logic, where thoughts drift without direction, where the body has gone very quiet and the mind is almost ready to follow. This is the place you come to every night. You pass through it on your way to sleep, though you rarely remember it. It is gentle here. It is neither one thing nor another. And it is safe. Breathe in and out. Let your thoughts be what they are. Let them drift past without grabbing at them, like marine snow, each one complete, each one falling slowly, none of them requiring your immediate attention. They will be there in the morning. The morning is a long way away. In, out. You know something now that most people don't. You know about the frilled shark. Not as an abstract fact, but as a living presence in the dark water of the deep ocean. 300 teeth, 6 frilled gill slits, an eel body that moves with sinuous patience, 80 million years of unchanged hunting. You know about the colossal squid, not as a fact in a book, but as something that moves in the cold of the Southern Ocean abyss. 27-centimeter eyes watching the dark, hooks instead of suckers, a beak that could crack bone, and a metabolism so slow, so calibrated to the cold that it needs barely 30 grams of food a day. You know about the marine snow falling endlessly from the surface world to the deep, about the biological pump that moves carbon from the atmosphere into the sediment, about the deep circulation that connects all the world's oceans in a single, slow river. You know things about the world that most humans have never thought about, and that knowing can be a weight or it can be a gift. Tonight, let it be a gift. The gift of scale, the gift of perspective, the gift of knowing that the world is vastly larger and older and stranger than any ordinary day reveals, and that in that vast, strange, ancient world, you are here, breathing, resting, safe. Breathe in and out. Somewhere above you, in the mesopelagic of the Southern Ocean, the frilled shark drifts. It has nowhere it needs to be. It has been nowhere it needs to be for 80 million years. The frilled shark does not have a concept of urgency. It does not have a concept of plans. It does not carry the weight of what it should have done differently, or what it needs to do better tomorrow, or what someone said to it that still stings when it thinks about it. It has gills and teeth and cold water and time, all the time in the world. The patience of 80 million years is a patience beyond comprehension. But we can approach it in the dark, at the edge of sleep. We can borrow for a few hours the stillness that the frilled shark never had to borrow because it never lost it. Be still now, the way the frilled shark is still, without effort, without agenda. Breathe in and out. The Southern Ocean we are in tonight has been in its current configuration surrounding Antarctica, swept by the Antarctic circumpolar current, cold and deep and isolated, for roughly 30 to 34 million years. 30 million years. Before that, Antarctica was connected to South America by land bridges. The waters around it were warmer, more connected to the tropical circulation of the ancient Tethys and Panthalassa oceans. When the Drake Passage opened, when the last land connection between Antarctica and South America finally broke and the ocean connected beneath it, the Antarctic circumpolar current formed. The world's strongest ocean current, driven by the strong westerly winds of the southern latitudes, unimpeded by any continental barrier. The opening of the Drake Passage changed the climate of the entire planet. It isolated Antarctica thermally. The continent cooled, ice began to accumulate, sea levels dropped, the ice sheets grew, all from one passage opening in the rock. One geographic event, 34 million years ago, reshaping global climate for the rest of geological time. Everything is connected to everything. Every event has consequences no one predicted. Breathe in and out. The darkness of the deep ocean is not simply a feature, it is a shield. The inaccessibility of the deep, the pressure, the cold, the darkness, the sheer difficulty of reaching it has protected the species living there from direct human exploitation in a way that shallow water species have not been protected. We cannot fish the 2,000-meter depths easily. Not yet. We cannot see the creatures there easily. Not yet. We cannot disturb the sediment and the communities there easily. Not yet. And in that inaccessibility, the frilled shark and the colossal squid and the 1,000 other species of the deep ocean have continued largely undisturbed. The darkness that seems like a limitation is also a kind of freedom. The inaccessibility that seems like isolation is also a kind of safety. There is something useful in being hard to reach. The deep places, physical, personal, are not always places of danger. Sometimes they are places of preservation, of continuation, of the things that need to be protected from the ordinary world. Breathe in and out. Beneath where you float, the seafloor continues. The abyssal plain of the Southern Ocean extends across vast, featureless distances, hundreds of kilometers of fine sediment laid down slowly over tens of millions of years, red clay from distant continents carried by wind and ocean current, the compressed tests of foraminifera that once lived at the surface, the occasional volcanic fragment from a distant seamount eruption. This sediment is a record. Core samples drilled from the Southern Ocean floor have given scientists some of the most precise climate reconstructions in Earth history. The oxygen isotope ratios in fossil foraminifera shells record the temperature of the water they lived in. The layers of the sediment are a calendar of the ocean's past, reaching back millions of years. The sediment beneath you contains the record of the ice ages, the warm interglacials, the opening of the Drake Passage, the great oxygenation event, if the core goes deep enough. The floor of the Southern Ocean is the most complete climate archive on this planet, and the frilled shark has been swimming above it for longer than most of those layers have existed. Breathe in and out. We keep returning to the eyes. 27 centimeters, because something about the colossal squid's eyes demands attention, even in the dark where they cannot be seen. The largest eyes ever evolved on this planet. Consider what that means for the colossal squid's experience of the world, whatever experience means for a cephalopod. Its visual field is enormous. It can likely detect movement across a wide angle in front of it. The density of photoreceptors in that 27-centimeter eye may give it a resolution of the visual world that no other animal can match at these depths. Every photon that enters those eyes is information. A bioluminescent flash from a distant shrimp, the disturbed glow of dinoflagellates marking the path of an approaching whale, the faint reflection of the squid's own chromatophores in whatever stray light exists. The colossal squid sees more in the dark than we can begin to imagine seeing. And it has been seeing this dark world through those eyes for millions of years of its lineage's existence. Those eyes have never needed to see the sun. They evolved specifically to see a world without it. Breathe in and out. Every dive must end. Every descent to the dark places eventually reverses. Not because the deep is unwelcoming, not because we are expelled, but because the surface is where we breathe. The deep is the place we visit, the place we go to find the parts of the world, and perhaps the parts of ourselves that require darkness and pressure to be what they are. The deep is not home. Home is the surface. Home is the light and the warmth and the ordinary world. Home is the bed you are lying in right now, and the deep ocean, with its ancient sharks and its enormous squid and its patient, cold, extraordinary darkness, will be there when you come back. It is always there, waiting, the way ancient things wait, without urgency, without need, simply being what they are. Breathe in and out. In the dark of your room, your brain is doing something interesting. In the absence of visual input, the brain does not simply go quiet. It becomes more active in certain regions. The default mode network, a set of brain regions associated with introspection, self-referential thought, and mind wandering, becomes more active when external demands are removed. This is the part of the brain that imagines, that reflects, that wanders through memory and possibility. It is the part of the brain that is most active right now, as your external world has narrowed to this voice and this darkness. The default mode network is associated with creativity, with the generation of new connections between ideas, with the processing of experience into understanding. Sleep is not a suspension of this activity. In sleep, the brain continues to process, to consolidate memories, moving information from short-term storage to long-term, to clear metabolic waste products that accumulate during waking, to strengthen the neural connections that represent the things you learn today. Tomorrow, you will remember today better for having slept tonight. Tomorrow, the things you thought about in this quiet will be more integrated, more available, more part of you. Sleep is not wasted time. Sleep is the time when everything else becomes more real. Breathe in and out. The Ross Sea, where most colossal squid specimens have been caught, is one of the most remote and least disturbed large marine ecosystems on Earth. In 2017, it became the world's largest marine protected area. 1.55 million square kilometers of ocean closed to most fishing and industrial activity. The colossal squid is one of the beneficiaries. Protection of the Ross Sea means protection of the toothfish the squid eats, protection of the krill the toothfish eat, protection of the entire food web that produces and sustains the colossal squid and the sperm whales that hunt it. Conservation of the deep ocean is not a simple task. The deep does not respect the lines we draw at the surface. Water circulates. Animals migrate. A protected zone is only as useful as the zones connected to it. But the Ross Sea Marine Protected Area is a beginning, a recognition that some things are worth protecting even before we fully understand them, especially before we fully understand them. The colossal squid is worth protecting, not because it is useful to us, not because it feeds us or entertains us or serves any immediate human purpose, but because it is here, because it has been here for millions of years, because an animal that evolved to see in the dark with eyes the size of dinner plates is simply an irreplaceable expression of what the universe can produce. Breathe in and out. Everything we have discussed tonight is true. And everything we know about the frilled shark and the colossal squid combined is a small fraction of what there is to know. The frilled shark's precise behavior in the wild, hunting strategy, social behavior if any, exact prey preferences, population size, range, is largely unknown. The colossal squid's life history, how long it lives, how it reproduces, whether it has any social behavior, how it communicates, what its daily movements look like, is almost entirely unknown. We have caught and described perhaps a dozen intact colossal squid specimens in all of scientific history. A dozen. For an animal that sperm whales eat regularly. For an animal that may populate the deep Southern Ocean in significant numbers. For an animal that may be the largest invertebrate that has ever lived on Earth. A dozen specimens. The rest of its life, the daily reality of being a colossal squid at 2,000 meters in a Ross Sea, remains in the dark where it lives, unseen, unknown, patient. Breathe in and out. The deeper you go, the more still the water becomes. At the surface, the ocean is in constant motion, driven by wind, by waves, by the tidal forces of the moon, by the heating and cooling of daily and seasonal cycles. The surface is never still. But at depth, the motion slows. Not to nothing. There are deep currents, slow and vast, but slow. There are no waves at 1,000 meters, no tides in any meaningful sense, no wind. The deep ocean is, by surface standards, extraordinarily still. And in that stillness, sound travels differently. The ocean has a layer called the SOFAR channel, sound fixing and ranging, where the speed of sound reaches its minimum due to the combined effect of temperature and pressure. Sound produced in this channel bends back into it rather than escaping upward or downward, effectively trapping it. Before human ship noise elevated the background sound level of the ocean, the SOFAR channel carried the calls of blue whales across entire ocean basins. A whale in the Pacific could be heard by a whale near the coast of Australia. Not metaphorically, literally heard. Sound travelling thousands of kilometres through cold, still, deep water. The ocean was once a place of continent-spanning conversation, and in the deep places far from the shipping lanes it still is. Breathe in and out. Before we go further, let us pause for a moment on krill. Because krill is why everything in the Southern Ocean is as large as it is. Antarctic krill, Euphausia superba, is a crustacean that reaches about 6 centimeters in length, barely longer than your thumb. And it exists in concentrations that are almost beyond imagination. A single krill swarm can cover an area of hundreds of square kilometers and extend tens of meters deep. The biomass of Antarctic krill in the Southern Ocean, the total weight of all the krill, is estimated at somewhere between 100 million and 500 million metric tons. 500 million metric tons of small shrimp-like creatures, the caloric foundation of the entire Southern Ocean food web. Blue whales come here to feed, consuming up to 4 tons of krill per day. Humpback whales, fin whales, sei whales, minke whales, penguins, seals, seabirds, fish, all of them ultimately eating krill, and the colossal squid. Young colossal squid eat krill, adults eat fish, and other squid that ate krill. The colossal squid is, at its foundation, assembled from krill, and the krill is assembled from phytoplankton. And the phytoplankton is assembled from sunlight and nutrients and carbon dioxide and the upwelled chemistry of the deep ocean, from sunlight to 6-centimeter crustaceans to 10-meter squid. Energy flowing upward through the food chain, concentrated at each level, assembled into increasingly complex and improbable forms. The colossal squid is, in a sense, concentrated sunlight. Breathe in and out. The Southern Ocean is the largest carbon sink on Earth. It absorbs more carbon dioxide from the atmosphere than any other body of water. An estimated 2 billion metric tons of carbon dioxide per year. Without the Southern Ocean, the concentration of CO2 in the atmosphere would be measurably higher. The warming of the planet would be faster. The ocean is not just where things live. The ocean is where the chemistry of the atmosphere is regulated. The ocean breathes. Not as we breathe, not with lungs and rhythm, but it exchanges gas with the atmosphere continuously. At the surface, molecules of carbon dioxide move from the air into the water if there is more CO2 in the air than in the surface water, and molecules of oxygen produced by phytoplankton photosynthesis move from the water into the air. This exchange is happening right now over every ocean surface on Earth. While you breathe, breathe in and out. The oxygen in your lungs right now, some fraction of it, was once dissolved in the ocean, produced by a phytoplankton cell, released into the atmosphere, carried on air currents, and breathed in by you. You are breathing the ocean in and out. The frilled shark belongs to the order Hexanchiformes, the cow sharks, and frilled sharks. The Hexanchiformes are considered the most primitive of all living shark orders. They retain ancestral features that more derived sharks have lost. 6 or 7 gill slits instead of the 5 of almost all other sharks. A single dorsal fin instead of 2. A terminal mouth. In the fossil record, hexanchiform-like sharks appear in the early Jurassic more than 200 million years ago. The frilled shark's specific lineage appears in the fossil record from the Cretaceous period 80 million years ago in forms nearly identical to the living species. 80 million years of near stasis. In those 80 million years, the Atlantic Ocean opened and widened. The dinosaurs thrived and then vanished in the impact winter of 66 million years ago. Primitive mammals diversified into horses and whales and bats and eventually primates. The primates became apes. The apes became humans. The humans built civilizations and wrote histories and descended into the deep ocean in submersibles to shine lights into the darkness. And the frilled shark drifted sinuously through its cold water, unchanged. Breathe in and out. How long does a colossal squid live? We don't know precisely. Most squid have relatively short lifespans, 1 to 2 years for many species. They grow rapidly, reproduce once, and die. A live fast, die young strategy that contrasts sharply with the long-lived fish and mammals that share their habitat. The colossal squid may live longer than most squid, given its size and the cold environment. Cold water slows metabolism and extends lifespan across many animal groups. Estimates based on beak growth rings, similar to the growth rings of trees, suggest that some individuals may be 3 to 5 years old at their largest sizes, perhaps longer. For an animal that can reach 500 kilograms, that is not a long time. But the colossal squid is not measuring its life in years. It is not measuring its life at all. It simply lives, grows, hunts, eventually reproduces, eventually dies, and when it dies, it becomes food for the bacteria of the deep, for the scavenging fish, for the isopods and amphipods that cluster on any large carcass. Everything returns to the system. Everything is recycled. Nothing is lost. Breathe in, hold, and out. There is something the frilled shark knows that we spend our whole lives trying to learn. Not in the sense that it thinks or teaches, but in the sense that its existence embodies something we intellectually understand, but rarely feel. That time is vast, and most urgency is small. That the things we treat as crises are, in the long view, weather. That the world has been here far longer than any problem we carry, and will be here long after any problem we face has been resolved or dissolved, or simply outlasted. The frilled shark has been here for 80 million years. Your worry has been here for hours, perhaps, days, at the most, weeks, for the most persistent. Against 80 million years of frilled shark, against 4 billion years of ocean, against 13.8 billion years of universe, the worry is very, very small. This is not dismissal of the worry. It is perspective. The perspective that the deep ocean offers, if you let it. The perspective that comes when you stop and consider what was here before you and what will be hereafter, and find that the answer is almost everything. And somehow, that is not frightening. It is freeing. Breathe in and out. The ocean has been here for 4 billion years. In that time, it has cycled through states we can barely imagine. The Hadean Ocean in the first few 100 million years was hotter and more acidic, bombarded by meteorites, subjected to a young sun whose light was different from today's. The Archean Ocean, where life first arose, where the first bacterial mats grew in shallow seas, where the first photosynthetic organisms began adding oxygen to the atmosphere slowly over billions of years, transforming the chemistry of the world. The Great Oxygenation Event 2.4 billion years ago, when enough oxygen had accumulated in the atmosphere to fundamentally change both the atmosphere and the ocean. For the anaerobic organisms that had existed until then, it was a catastrophe, the equivalent of a global poisoning. For the organisms that could use oxygen, it was the beginning of everything. The Cambrian explosion, 540 million years ago, when animal life in the ocean diversified explosively. Within a few tens of millions of years, every major animal body plan we know today appeared in the fossil record. Eyes, mouths, legs, wings in their pre-wing form. The whole animal architecture of the planet, invented in geological eye blink. And in all of that, through the ice ages and the warm periods, through the extinctions and the diversifications, through the opening and closing of ocean basins and the drift of continents, the ocean was here, changing, but here, patient, but here. The ocean has always been here, and tonight it is holding you. Breathe in, hold, and out. Beyond the depth where we float tonight, the ocean floor continues. The Southern Ocean abyssal plain stretches northward from the Antarctic continental shelf, reaching depths of 4,000 to 5,000 meters across vast, flat, expanses of sediment. These plains are among the most remote places on Earth. No sunlight, temperatures near freezing, pressures that would destroy any surface-built machine not specifically engineered for the deep, and yet, life. Sea cucumbers move slowly across the sediment, ingesting it, processing it, leaving clean trails behind them. Brittle stars extend their 5 delicate arms and wait for particles to drift down. Isopods, giant isopods, some of them 30 centimeters long, looking disturbingly like very large pill bugs, scavenge whatever falls from above. Deep-sea fish hover in the water column above the plain, waiting for the scent of a food fall, a whale fall. The carcass of a dead whale reaching the seafloor is a feast for the abyssal community, providing food for decades as the bacterial mats consume the organic matter and the scavengers work through the bones. The abyss is patient and opportunistic in equal measure. It has time. It always has time. Breathe in and out. Is the colossal squid aware? Does it experience anything? The question of animal consciousness is genuinely unresolved. Philosophers and neuroscientists disagree about what consciousness is, what it requires, and which animals have it. Cephalopods, the group that includes the colossal squid, have complex nervous systems. The octopus has more neurons than a dog. Cephalopods have demonstrated problem-solving, play behavior, and what appears to be individual personality differences in laboratory conditions. Whether the colossal squid, in its cold, dark world, has anything like subjective experience, whether there is something it is like to be a colossal squid, staring out at the black water with those enormous eyes, we cannot say. We cannot say because the question may not have a clean answer. Consciousness may not be a binary thing, present or absent. It may exist in degrees, in kinds, in forms that don't map cleanly onto human experience. A colossal squid's experience of its world, if it has one, would be profoundly alien. A world of pressure and cold and near absence of light, perceived through eyes tuned to detect bioluminescent flashes, through a system of chemical sensors, through the pressure sensitivity of a lateral line system. A completely different experience of being alive, but perhaps, in some sense, an experience. Breathe in and out. The frilled shark is, in a sense, a ghost from a world that no longer exists. The Mesozoic ocean, the ocean of the dinosaurs, was different from today's ocean, warmer at depth, different in its chemistry, populated by creatures that no longer exist. Mosasaurs and plesiosaurs, marine reptiles that no longer exist, ammonites, coiled cephalopods with hard shells, relatives of the nautilus that dominated the Mesozoic ocean and then vanished in the extinction event 66 million years ago. The frilled shark saw all of this. Not this individual frilled shark. Individual frilled sharks live decades perhaps, not millions of years. But the lineage, the unbroken chain of frilled shark births and deaths that stretches back 80 million years. In 80 million years of frilled shark birth and death, the ocean changed around them. The water warmed and cooled. Species evolved and went extinct, continents moved, and the frilled shark lineage continued. Adapted slightly, the evolution is not perfectly zero over 80 million years, but adapted enough to survive, not so much as to be unrecognizable, a ghost that is still alive. A visitor from the Mesozoic that never left. Breathe. In, hold, and out. Although we are in the Southern Ocean tonight, the frilled shark ranges across the Pacific, the Atlantic, and the Indian Ocean as well. Frilled shark specimens have been collected off the coasts of Japan, Australia, New Zealand, Chile, the Azores, Norway, South Africa, and the eastern coast of the United States. A nearly global distribution at depths between 200 and 1,500 meters. But they are never common. They are always rare finds. Deep-sea fishing operations occasionally bring one up, and when they do, it makes news because the frilled shark is unusual enough, alien-looking enough, that a photo of one invariably spreads across the internet within hours. Scientists catch prehistoric shark, living fossil found off coast of wherever. These headlines recur every few years as another individual is caught somewhere, and each time people are shocked, but they shouldn't be. The frilled shark has been there all along, in the dark, patient, unchanged, just rarely brought to anyone's attention. Most of what is extraordinary in the world is rarely brought to anyone's attention. It simply exists, doing what it does in the places it belongs, unwitnessed and unconcerned about being witnessed. Breathe. In and out. Let us be honest about how much we don't know about the colossal squid. We do not know how it reproduces. We have never observed mating behavior. We do not know where or how it spawns. We do not know what its eggs look like, or where it deposits them, or how long they take to hatch. We do not know how young colossal squid grow. The sequence of stages between hatching and the massive adults we occasionally catch. We do not know precisely how deep it goes. 2,000 meters is a reasonable estimate based on where we catch them and where we find their remains in sperm whale stomachs. But sperm whales dive to 2,000 meters, not deeper. Does the colossal squid go deeper beyond the reach of its primary predator? We don't know. We do not know how many colossal squid there are. Population estimates exist, derived from the number of beaks found in sperm whale stomachs multiplied by estimates of how many whales eat how many squid per year. But these estimates have enormous uncertainty bands. We do not know the maximum size a colossal squid can reach. The largest specimen ever caught may not have been anywhere close to the largest individual alive. We do not know its lifespan with precision. We do not know its social behavior, if it has any. We do not know how it communicates, if it communicates. For the largest invertebrate on Earth, a creature that has been known to science for a century, we know remarkably, almost shockingly little. The colossal squid keeps its secrets, in the cold, in the dark, in the depths where we cannot easily follow. Breathe, in, hold, and out. 300 teeth, 25 rows, each one tricusped, each one curved backward, each one a small mechanical trap, 300 of them working together in a mouth that represents 80 million years of uninterrupted refinement, not changed because not needing to change. The frilled shark's teeth are a kind of perfection, not the perfection of the ideal or the absolute, but the perfection of something that works so well that nothing has managed to improve on it. In 80 million years of ocean evolution, no variation of the frilled shark's teeth performed better than this arrangement. No slightly different cusp angle, no slightly different row number, no slightly different backward curve. This is the answer. These are the teeth. There is something almost restful about that. About something so thoroughly, so definitively, so completely solved. In a world of constant change, constant optimization, constant pressure to be different and better and more. A thing that has already found its answer and no longer needs to search for one. 300 teeth in the cold dark. Already perfect. Already complete. Breathe in and out. Your body has been preparing for sleep for a while now, not because of any effort on your part, but because your circadian rhythm, the 24-hour biological clock built into every cell of your body, has been coordinating this preparation since before the sun set. As your internal clock detected the decrease in light, it began a cascade of hormonal and neurological changes. Melatonin, produced by the pineal gland, began to rise. Cortisol, the alertness hormone, began to fall. Your core body temperature began its nightly drop, a decrease of about 1 degree Celsius that is associated with sleep onset. The blood vessels in your hands and feet dilated, releasing heat from your core to your extremities, explaining why your hands and feet are often warm just before sleep. Your brain began producing more alpha waves, the electrical signature of a relaxed but still alert brain, and then, gradually, more theta waves, the signature of early sleep. All of this without your conscious direction, all of this running on ancient biological timekeeping. Your body has been moving toward this moment all day, and you are almost there. Breathe in and out. 2,000 meters below the surface of the Southern Ocean. The colossal squid is somewhere in this dark, its enormous eyes scanning. The frilled shark is above us in the mesopelagic, drifting on currents that have circled Antarctica for 30 million years. The marine snow falls. The pressure holds everything together. The cold keeps everything slow. And you are here in the quiet, in the ancient dark, breathing. Your breath is very slow now, very slow. The kind of slow that belongs to deep rest. The kind of slow that belongs to something that has put down what it was carrying. Put it down, whatever it is. Just for tonight. You can pick it up in the morning if you still want it. But for right now, just breathe in and out. Let the dark hold you the way the ocean holds the colossal squid. Without judgment, without urgency, without light, just depth and pressure and cold and the patient, faithful dark. Is it possible that there are things in the deep ocean that make the colossal squid look small? It is not an unreasonable question. The colossal squid is the largest known invertebrate in the ocean. Known. The deep Southern Ocean is poorly explored. Nets deployed at depth capture what blunders into them, which is rarely the largest individuals of any species. Larger animals have more power to escape, are rarer, and range over larger areas. What we catch is a sample. A very small, very biased sample. The deep ocean below 2,000 meters across all the world's ocean basins has been directly sampled in a fraction of a percent of its total area. We have better maps of the surface of Mars and Venus than of our own ocean floor. In 2021, scientists exploring the Ningaloo canyons of Western Australia discovered a siphonophore, a colonial animal related to jellyfish that extended for 47 meters. 47 meters, the longest animal ever recorded, in waters that had been nominally studied. What exists in the truly unexplored areas? In the deep trenches, in the polar abyssal plains, in the seamount chains that no submersible has visited? We don't know. We genuinely don't know. Scientists who have studied the deep ocean for decades tend toward humility on this question. Not because they believe in monsters, but because the ocean is large, poorly explored, and has consistently produced organisms larger, stranger, and more extraordinary than anyone predicted. The giant squid, Architeuthis dux, was considered a myth, a sailor's tale, an exaggeration until 1857, when specimens began to be formally described. The colossal squid, which is larger, was considered likely to be mythological or wildly exaggerated until 1925. What is, right now, considered likely to be mythological or wildly exaggerated? We don't know that either. But the ocean does. The ocean knows what it holds, and it is in no hurry to tell us. Breathe, in and out. We begin to rise. Slowly, from 2,000 meters, up through the cold, still water of the Southern Ocean abyss. The colossal squid is somewhere below us now, those enormous eyes watching something we cannot see. Patient, ancient, at 1,800 meters, still cold, still dark, but rising. At 1,600 meters, the pressure lessens, imperceptibly but measurably. At 1,400 meters, somewhere above, the frilled shark is drifting. It has no idea we were here. It has no idea we will be gone. It drifts as it has always drifted, through the cold and dark. Breathe in and out. At 1,200 meters, at 1,000 meters, the threshold, midnight zone to mesopelagic, you cross it, rising. At 800 meters, still dark. At 600 meters, marine snow drifts past you in the dark, falling while you rise. At 500 meters, in, out. At 400 meters, above you, for the first time, the faintest suggestion of blue. Not light, not yet, but less dark. The dark that precedes light. At 300 meters, blue, deep, cold, Southern Ocean blue. Your eyes, if they were open, might just begin to perceive it. At 200 meters, light, filtered, blue-grey, quiet, the twilight zone from below. At 100 meters, brighter, the surface visible above as a shimmering ceiling of cold silver. At 50 meters, breathe in, out. At 20 meters, the swells of the Southern Ocean move overhead. At 10 meters, the surface is right there, and then you are back, in your body, in your bed, in the warmth, in the dark of your room, not the dark of the deep ocean, your dark. The dark that belongs to you. Breathe in and out. Your body is warm, your body is heavy, your body is completely held by whatever surface is beneath you. The frilled shark drifts in the dark of the mesopelagic, in its ancient world, patient, unchanged. The colossal squid waits at depth in the southern ocean, its enormous eyes scanning the dark, waiting, ancient. Both of them doing exactly what they have always done, and you are here, warm, still, breathing, in, out. The world does not need you to be awake in order to continue. The frilled shark does not need you to be awake. The colossal squid does not need you to be awake. The marine snow falls whether you watch it or not. The Southern Ocean circles Antarctica, whether you're conscious or not. Everything is fine. Everything will be fine. You can sleep. In, out, sleep. If you have not already, sleep. Your body knows how. It has always known how. In, out, sleep. The deep ocean is beneath you. Not literally, but it is there. 2 miles below the surface of the nearest ocean in the cold and dark. The frilled shark, the colossal squid, the marine snow, the patience of ancient things. They are all there, and they are fine. And you are here, and you are fine. In, out, sleep. The ocean keeps its own time, not your time. Not the time of urgency and alarm and things that must be done. The time of the deep, the time of the cold, the time of the patient dark that has been patient since before the first animal swam. In that time, you are a brief, warm, breathing thing. And brief things deserve rest. In, out, sleep, deeply, quietly, all the way down. Follow unseen ocean history for more deep ocean mysteries and sleep. In, out,